use NetMaven. After completion of integration between the ENAC and ICE, we are now going to design our network hierarchy. So first, click the hamburger menu, network hierarchy. First, we create an area, it's called testing, and my building called CLAB, and we're gonna add a flow, give it full name, flow, fifth flow, phone number. If you have a floor plan, you can drop it here. Is now adding my floor plan. Everything looks good. Click add. Please enter value. Say that's 50 feet, 10 feet high. Yes. Okay. So now we're going to click the hamburger menu, network settings, under testing. By default, it gives you DHCP server, DNS server, and if you want, you will go to add AAA server, NTP server, still watch flow destination. That's for the net flow. I don't have it. Just click OK. So let's check first AAA server. Click network because we need to manage the network device. AAA also we're gonna authenticate, authorize it clients endpoints. So click AAA. Okay, that's ICE. Gonna use radius. That's our ICE IP address. Also is ICE for client. Protocol radius IP is our ICE. Go ahead next. DHCP server 10.1.2 to 40. DNS server. DNS domain name clab.com. Primary. For NTP 10.8.25.131. So we get to next device credentials. Let's see if it's gonna saved. Oh, it's now saved. Gonna say I can retype it. I retype it just for you to remember. You have to save it first. The next I go device credentials. I'm gonna add the CLI. We'll give a name device admin. That will be admin, and password already there. And we're gonna assign the credential, save it. Make sure apply to close. device admin. Great, everything looks good. I'm gonna add one SNMP read. I'm gonna say CLAB RO. Show it CLAB RO. Assign, save it. So next, we're gonna give it another one. CLAB RW. CLAB is fine. CLAB RW. Okay, sign, save. Let's see what else. Add HTTPIs. This will be added when we adding controller, only for controller. I don't need to add it in a testing level. When I added the controller, we just add it for the controller only. Okay, close it. So for now, close it. We'll do IP address pool. We're gonna make sure gonna edit global address pool. The global level. Gonna add a big range. So first, or say overlay pool genetic. What's genetic? Okay, subnet overlay into our subnet with 172.16.0.0 and /20/16 gateway 16.0. That's it. Save. All right. We have other subnet. It's underlay pool. It's gonna be huge. 10.0.0.0. That's /a 10.0.0.1 as a gateway. Save it. That these two are our global IP address pools. So for if I have a small sites and floors, buildings, where they're gonna to carve out from these pools. So now we will create a global IP pool. I'll head back to a 4.5. Let's go to 4.5. That's 4.5. Okay, I'm gonna reserve first pool Win7 pool 1, right? From a global pool overlay pool. That is /24 subnet 172.16.1.0 gateway 172.16.1.24254 DHCP. We should have reserved. Let's cancel it. I'll do it again. What's going on? We should have DHCP. Now for DHCP, we're gonna just click add. So you can add it here. Okay. click it. This gateway is going to call any cast gateway. So showing you the overlay diagram. The gateway can be here, can be here, can be a controller. It can be anywhere inside the fabric. Okay, that's the VXLAN function. Okay, click reserve. So first the pool. Okay, that's keep adding reserve. That's 17 pool 2. Pool gonna also reserve from overlay pool. Now gonna be 24. Edit. Reserve. Let's reserve third pool. Check reserve. Then I'm gonna add do another reservation um, for the AP pool. So AP pool land. Remember, APs are going to register controller from their underlay pool. So underlay, okay. Similar. Let's slash 24 for our APs. 10.0.3.0 10.0.3.24254 DHCP server reserve. So next we're gonna reserve network to ASA. The pool, global pool, will be overlay, and the network is /24 subnet 72.16.10.0. We don't have a gateway, we don't have DHCP, we don't have a DNS server. Click reserve. This time, sorry, it's not genetic. It's just once you create it, you cannot change the type. Click reserve. I'm going to explain to you why we create the two ASA pool. This is the /24 172.16.10.0. If you look at my overlay diagram, I have two VN, CLAP VN, CLAP VN2, and we could have CLAP VN3, VN4, VN5, many. So this one is the lab will have two. So the pool to ASA is subnet between the internal VN to the external. Okay, so when I will create a VN, it's gonna pick a /30 as an external interconnect subnet. Okay, and similar to VN2, VN1, VN2. They're gonna carve out from that two ASA IP address pool and make it a slash 30 for interconnect to the external. In this case, where we the ASA. So next, we're going to reserve one more. Let's say external then extended pool. Give it a LAN for the underlay. So 24 of 10.0.6.0 gateway 10.0.6.254 DHCP DNS click reserve. So what this pool gonna do? Let me explain you with this slides. For in case you have to access more of the switches, the third party or switches don't support the fabric, so you can plug into our edge nodes, and there will be a trunk between the edge and your third party external node. It will automatically generate a gateway. From you just need to for a VLAN, a gateway for a VLAN, and if you want to access from the extended nodes, they're just gonna to assign that port to the VLAN and you through the trunk into the fabric site. Okay, so we'll create reserved everything pools. Now let's have to our DHCP server. We'll create a 3 scope. Each scope is gonna have a domain name, DNS server, and router. So 3 things for pools. Each pool we have 3 options, but for the AP pool, we'll add option 43. That's vendor specific info. This is the hex code, of the IP address controller. So it's been a long time, and you probably gonna know how DHCP is gonna work. But how DHCP gonna work in SDA network? That's what we're going to explain to you. If you see this flow chart, what we call flow chart, you will find is a client trying to request IP. You send a DHCP request to the edge switch. The edge switch, of course, in traditional network, you will send to the DHCP server, and this will reply back IP using DHCP relay. Okay, it's relate. Okay, so but in this case we have many we call it edge, and the client could request IP in any of it the edge device, right? Then if they try to request from the edge, and the relay message will put a option 82. The 82 is actually SVI interface. So in this case, DHCP will apply a DHCP with IP address to the relay interface, which is the SVI. But when we have a lot of edge and clients moving around and still having a same gateway, the gateway can be on every edge devices. So in this case, we will still sending option 82 as a relay message for the SVI to the DHCP, and also we're adding alloc to the border. Allocks to the border, so the border will know which edge is relaying the DHCP request. And when the border knows where the edge is, it will forward to that edge node because it knows the alloc of that edge device. And that way, the DHCP is sent to the client.